This conference will now be recorded.
Hello, everyone. I'm very glad that you're here. Today, I have a very interesting session for you. The main topic is digitalization and optimization of production processes, lessons learned from the metal processing cluster. And actually, we'll have two sessions inside this one webinar. So we'll have two presenters. One of our presenters will be Mr. Michał Wojnarowski. He'll be telling us about additive manufacturing. And afterwards, we'll have presentation from Mr. Sebastian Rynkiewicz, who is a coordinator of the metal processing cluster. He will be sharing experiences from the MPC. Before we dive into the agenda, before we tell more about the content, I would like to tell you a few words about technical aspects. As always, our session is being recorded, so you'll have access to the recording afterwards. If you have any questions, do feel free to ask them during the session, or afterwards we'll have Q&A part where you can ask questions. So you only need to put it in the chat or in the questions pane. I'll forward it to the presenters and we'll be answering them. So this is for the technical aspects, and I think we can continue to the main topic. So we'll start with the session Orders Flow Process Optimization Going Digital by Mr. Michał Wojnarowski. Let me switch the presenter rights.
Okay, so I'll introduce myself again in a moment. Just let me start sharing my screen. Okay, is that all visible? Just let me know. Yes, that is visible.
Yes.
But first I need to
works.
go back. I was doing some review. So, hello everyone. It's great to be here. It's an honor to present. And yeah, a few words about me. I'm in additive manufacturing since 2012. With a small break for energy industry, and right now I'm a project manager in technology applied. I'm actually dealing with processes, so it's actually a great opportunity to present this issue to you. So I will try to condense a very broad topic to really something small, because we're dealing with not only the order flow process but also the supply chains. And how these two things actually play together. So that's the agenda, more or less. So maybe a few words about Technology Applied. So Technology Applied was founded in 2015 with 3D printing in mind. And well, we're one of leading Polish service bureaus in this regard, and we specialize in SLS technology. We're based in Białystok in Poland, in Białystok Science and Technology Park. So you're welcome to visit us anytime you want. So we offer all the major technologies apart from SLM yet. And yeah, so that's the further things we will discuss. About Technology Applied we already did. So let's get to it. Let's talk about additive manufacturing. Probably most of you are familiar with it, but just for the sake of it, I would like to give a brief introduction where additive manufacturing places itself in the supply chain. So anytime the time is critical, anytime parts are very geometrically complex, when we need a small batch, very often we need a small batch very quickly. That's usually the case. And when parts need to be customized, or when we need prototypes. So these are the instances where additive manufacturing is your best bet. We still believe that there's still much more area for additive manufacturing to expand. So, but let's get to the process. This is actually probably the most annoying things to people, to companies that work in this industry. So what is great about additive manufacturing? It's that it doesn't matter whether each part is different or they're all the same. But that's also the most challenging part. If you can probably imagine that when you have a process, let's compare it to traditional methods like injection or CNC machining. You usually design the process for one part and then continue, so you can iterate and finally get the perfect process. In our case, the whole production line, it's usually always different parts, so that brings many challenges to actually managing this whole process. And but we will discuss these problems on the digital side. So manufacturing process in our case, and probably it's the same in most companies really. So we get the file or we don't, then it's the design part. It needs to be suitable for 3D printing, and of course suitable depends on what technology we're dealing with. So file needs to be repaired or modified. So over here we have much more options, but I would say the industry is not yet that open to these more advanced options, let's say. So final quotation can only be then provided using a pricing algorithm. If customer accepts the code, the file is queued for production. Then the operator prepares the build platform considering all the requirements, so puts together all the files and all the prints. Then we have the print process, and of course, if there's print processing required, then the print goes to the post-processing, packaging, and delivery. So you see, we will be discussing, I will present mostly issues related to the first couple of points, where we're still dealing with the digital file. So we have 4 major digital elements in this process. So first of all, we have the file delivery. All of these will be discussed in next slides. Then we have 3D model processing, which is probably the most interesting and the most unused as of yet. Then we have the quotation and platform preparation. So let's start with file delivery. Right now, in practice, it's either sent via email, sent through a file sharing platform or an FTP, which is, we transfer basically. And sometimes even delivered on a USB stick. And this really happened. In our vision, which will be explained a bit further in more detail, we believe that a system should work in a way that files are always uploaded directly into the system by the customer, so the file is not sent through other means. Then we have 3D model processing. This stage includes file evaluation, file repair, or file modification. So in evaluation, we need to see whether this is a suitable model to be 3D printed. So we're talking about wall thicknesses and some geometries, or perhaps simply there's an error in the model and it doesn't work. Sometimes it's an issue of units simply. But most of all, it needs to be watertight, so the machine can print all of its parts. And when we have lots of modifications and suggestions, the file needs to be sent back and forth between us and the customer, which is really inefficient, takes time. So iterating that file poses some security risks, one might say, and it's basically inefficient. So in our vision, all modifications should be done within the system. So both client and service bureau can work on the same thing. So basically collaborative elements. Then quotation. So quotation can be done either manually, simply by calculating. No one does that, but for the sake of it, I'll present it. And by calculating model volume by price of each volume unit. Of course, that process is time-consuming and prone to error, but and also most technologies, basically powder technologies, the function of price and size is not linear. So it's each, let's say, square centimeter, it is not. So 1 or 2 square centimeters is not equal to 1 + 1 very often. This part is easiest to implement, but of course you need to trust your pricing algorithm. So that's the most important thing, because if there are some errors, then there's no other way to check it further on. Platform preparation. So what you see here on the picture is the build platform being prepared. So this is the area where service bureau actually optimizes the whole process, the whole schedule, so we can fit in more parts in the same process, but also more efficiently use powder. In case of SLS, the powder that was used in the process and not used for the print deteriorates, so you need to mix it. So the more parts you fit in, the better. But at the same time, you need to consider thermal aspects. So certain shapes need to be positioned in different areas of the platform. So you can do it either manually or automatically with using the algorithm that does it in the most optimal way. But so far, we really have not seen an algorithm that would do it as efficiently as a human being can do. So there's still a lot of work to do in this regard. And this now leads to our digital warehouse idea, which we started conceptualizing, and we by introducing certain elements of what I have presented so far. Like we have of course the quotation, and we have upload capability, and but in order to really materialize this idea, the customer needs to hold his parts and on a platform that we can also work within, so he can work within. And that means that when he orders a certain part regularly, he doesn't have to go through the whole process every time, because right now, even if he does, we still need to validate, we need to check with him. So it's still going back and forth because he doesn't see our parts in our folder, let's say. But in this case, when he sees all the parts he needs, then his order goes straight to our production queue. Of course, it would work best if it was automated. That means our system would be somehow integrated with his MES system or ERP system, and this is something that is really lacking. So we have various systems that offer this kind of functionality, but still means that a company that needs a part needs to have an employee that actually oversees all these parts and makes these orders. So he cannot do it from within his system. So let's say they produce a machine, and it's not that they see within that system whether they have this part on available, is it already ordered. Someone has to manually check, let's say our software, our website where he can log in, that this part is ordered. So that's the whole idea of greater integration, and this is lacking currently. So we cannot realize this greater additive manufacturing integration into modern supply chains. And such digital warehouse would provide better communication between the client and the contractor. It would definitely simplify the ordering process, therefore reduce the cost, eliminate human errors within that. So it can always, and it did happen that some parts were simply confused. It happened with us, it happened with the customer, especially when there was various iterations of the file. So when the customer sent us another one, then we suggested changes. So in the end, people got confused, and you had, of course, you can end up like in all digital work, that you have final version, final, and final version 3. So this collaborative aspect is very important. And then, again, better security. So as I mentioned before, the more file travels, the more insecure the process becomes. So the system should be tight, and by keeping file within the system all the time, it's definitely much more secure. So when we started implementing parts of the system, we're actually thinking about setting it up on our own server within the company. But the problem with that is it then takes time for any updates to be implemented. But you can, in order for this process to be very secure, you can do it either on a local server, so putting aside all the problems that can happen, or you put it on top of a cloud provider, which is the solution that we're using currently. And then again, when everything is within one system, it allows for traceability of the file. So, but if the file is taken from the system, then sent via email or through any other means, that means it's already somewhere there. And in a system where it cannot leave that system, then it's much more secure. So in our opinion, traits of a good order flow process are as following, as you can see. Should be tight, means that there should be no information leakage. It's either intentional by sharing, as I said, during collaboration, or not intentional, that is security breach. Complete, which comprises, so it has all the elements like file delivery. So you simply the customer uploads the file. It can be, all the file can be processed there, because right now we need to take that file, edit it in any of the application suites that simply do it the best, and then put it back in the, let's say, in the folder. And build platform preparation. Again, every machine is different. Not all of not all of the software can do it properly. So again, we need to take it and prepare it outside. Once the file is complete, we know which one. We need to take it and put it in a different software that is best suited for nesting, which is putting the whole build platform together. And enabling collaboration. So our customer and us, we can both work on the file, present suggestions, we can iterate, and all the versions are easily identifiable. That would definitely speed up the process of communicating with customer, and it would be easier for companies like us, for the service bureaus, who are much more, let's say, fluent in all the techniques that and advantages that additive manufacturing presents, which I will show you on the next slide, which is very interesting. And working within such system would be of great benefit to everyone. For us, because we will increase our sales most likely, and also for the customer, who would gain, of course, well, save money on more efficient designs. Then again, traceability, which we have set, and of course integrated. So there is some software that covers many parts of such system. However, we have so far not seen something that easily integrates with CRM systems, especially. So the software that is available on the market, various versions of it, provides some basic CRM capabilities. But if you need something more advanced, then again, the file needs to leave the system, go to another system. Again, it's jumping back and forth. Sorry, the part of it is in Polish, but I forgot to translate it. In any case, coming back to the point of collaboration, was do a little bit better communication, proposing some significant changes to the model. Here we have the idea. You have the original design. You don't see my cursor. Original design, and then you can optimize the topology, and you have a redesigned antenna bracket. So as written below, the part is now as strong as was before, but it's lighter by 40%. So being able to collaborate with the customer readily would allow us to propose such solutions, and it would be probably easier to present it to him. Again, you have various parts in conventional design, and then you have laser sintered design. This is another great advantage of additive manufacturing, that you can actually, if you change the philosophy of thinking about production, you can actually combine many parts into one part and then have it 3D printed. So why 3D? Because of speed. You know, there's no need to prepare tools for a specific detail. It means that production can be started immediately. And of course, flexibility. So no upfront costs associated with the necessary tooling to manufacture the product, and freedom in modifying parts geometry. And why digital? So digital is a bit misleading because we're dealing with files. So of course, these are digital objects. But in terms of digital, we mean greater integration between additive manufacturing providers and let's say traditional users of other manufacturing solutions. So digital would mean increasing the speed of order fulfillment, ongoing monitoring of orders and stage of implementation, minimizing possible human errors, and reduction of cost of preparing documentation. So let's say our idea really is to have some sort of window into all the SAPs and all these kind of systems within large contractors. So from there, they could simply treat us as another subcontractor, and then we could also work within our system, but still, let's say, on the same file, and simply send the file back to them. Not the file, but the ready final print. And why we believe we should increase the involvement of additive manufacturing within the in industries is because of the growing concentration. The best example, we even made a report on that some time ago. Best example was the COVID pandemic, when all the world was cut off. When they closed down Wuhan, suddenly one of the major manufacturing centers of the world was closed down, and many manufacturing companies ceased to have access to essential parts for their production. So what we are trying to propose, what we're promoting, is to more decentralize production. But of course, in order to do it, it needs to be very efficient and optimal. Then also, traditional production methods are not as flexible as additive manufacturing. And then the cost. But of course, the cost plays a role only when you need to have it in a smaller batch. Okay. So our conclusions and recommendations is to have initiatives like this one for all the stakeholders and industries to have discussions, to share these sort of challenges, to for the knowledge to diffuse, and perhaps someone can come up with something that let's say we're presenting, what sort of challenges we're facing. Definitely more and better software solutions are required, and we need, which is an extension to what I said, to what I just said, is definitely more cooperation, more integration between service providers and customers. And for that reason, we need to spread knowledge about additive manufacturing. And the more people understand it, the more know it, the more advantages of 3D printing they see, the better for everyone.
Thank you very much. Now we'll switch to the second part of the presentation. If you have any questions regarding this first part about additive manufacturing, do feel free to expand the GoToMeeting control panel and put your questions there. Afterwards, I will forward them to the presenter. So
Well,
if
that
you
was
want
longer
to ask
than I
something,
expected, sorry.
do feel free. And now let me switch to Mr. Rynkiewicz. and he'll be sharing experiences on a metal processing cluster with you. Okay, I can see the slides of Intelligent Superfactory. So floor is yours.
Thank you, Zbigniew. Hello, everybody. It's really nice to be with you, and I would like to present our presentation for metal processing cluster. My name is Sebastian Rynkiewicz. I'm a chairman of the board, and we are the key national cluster in Poland at the moment. The same headquarter like Technology Applied. So I started with topic of our case. So Intelligent Superfactory is develop crowdsourcing superfactory for cluster, which allows synchronization of planning and development of joint products realized by disaster companies, sources in fact. So what is really important for us at the moment? Our case is not finished at the moment, so I would like to present you in the agenda of this case a few stages of our work and of course summary what is conclusion on this moment, and I hope that we also will have interesting discussion during session questions and answers, but also in further steps of our project DigiFoF. So where we find our idea, what is really important for our cluster, bottom-up method. So we work on different experience from companies, from authorities, from R&D centers, from business security organizations. So we find three stones really important for our work: openness, trust, and funding. The other aspects of idea of Intelligent Superfactory was that very interesting technological park by our members. In fact, two main reasons: development pension, because of previous times during the communist time we have not so huge development of technology, so we started a relevant low level of technology, but EU funds effects put on us on quite high level of technology advancement. You saw before the presentation of Technology Applied, that is one of example, more than 50 companies which are on the really huge level of technological advances. So the further things is interest of our regional authorities and also the European Commission, because during the visit of European Commissioner in our region, when politics heard about our ideas, they think, okay, this is really interesting. We discussed with also World Bank experts about our ideas, and they put the question that you see your ideas in reality, and our answer was no. And also the experts from EU Commission said we also didn't see good examples of intelligent superfactory. So let's go on. Let's try to find optimal solutions. So we are looking for good, but that is really important, bad practices. So if during discussion or my presentation time you have any idea, we are really open for your ideas and remarks. So the one further point of background of our idea was international activities. During the last few years, we was really active on the fairs, on the seminars, on the workshops in different parts of Europe and also world. More than 50 activists during 1 year. So we built, of course, also in the DigiFoF project, pan-European network of our partners. So that was also really important for these projects. And the last but not least, passion of people who was engaged in our projects. So we find in the first stage of our project or idea realization, and we started with endogenous model with preparation and pilotage stage. When we finished this stage on the first Warsaw Industry Week, and what we do before, we find 3 main challenges in few aspects: business, conceptual, and technical transformation. We realized this process in one of our bodies, Enhanced Cooperation Group. We have 7 of these groups. The dedicated group for these challenges was technology. So we have ability to offer more complex products and services not possible to be delivered by single partner. That was the experience of our first activities, that our common proposition is more attractive than just single company can do that. Also, really interesting piece was better utilization of available resources, mainly machines. Why? Because after EU funds, our companies dispose quite interesting technological park, like I said before. But when we think about using of these machines, using of technology, we summary that only in 30% when we look for activities in 24 hours per day and 7 days in a week. So we see that, okay, we have bigger possibility of activation of our technology, but it's really hard to make this in reality. So possibility to participate in larger business deals, orders, and so on. So after business transformation, we also discussed about conceptual transformation. No common office, personnel for ordering process, and etc. It's possible to distribute, synchronize this work. The answer was yes, probably yes. That is interest for us. Responsibility for services and maintenance process. That was also the big question, because when we see that that is possible to realize some really interesting deals or orders, the problem was who will be the leader of this activity. So monitoring system must be established when we start to thinking about these challenges. And also technological transformation. No common IT platform, including monitoring, of course. Inventories are not synchronized. A lot of technology, a lot of producers of technology is problem to common connection with different technologies. And also sensors for automatic inventory management is really important, and that was also for us a big challenge. But after our discussion, when we prepared some proposal in a few pages, people with passion, that is the point about I said, prefer the first demo lab for the Warsaw Industry Week fairs, and they made it in few days. In fact, that was the holiday time in Poland, and in this time I was engaged with my friend in cluster-to-cluster event in Stuttgart, and when we come back to Poland, to Warsaw, I only phoned to one of our technological expert and put the question, it works? And he answered, no, but tomorrow we will be ready. So without passion, that was not possible to create our first pilotage model, and we in fact acting of our endogenous potential in cluster. And what was the reaction of our external partners when we be on this ferries in Warsaw? That was really interesting, because we have the question, you show us few days ago concept on the paper, and if I good thinking, I can see that proposal in the reality, and that was true. When we started to make inventarization of our possibility, we see that we've got most of the technology in our case, in our hands: automatization and robotization, mechanical engineering, system integration, Internet of Things, cybersecurity, cloud computing, additive manufacturing, like you see before, technology apply, AR and VR technology, also big data. So we, like a coordinator, metal processing cluster, we can do most of the technology, and that was the reason when we first time started to go to the exogenous model, and we start to discuss with our Ministry of Entrepreneurship and Technology to try to propose preparation of some model of a competence center in the model of collaboration of the different partners in integrated system. And that was a really short program. We have only 1 month for realization of this challenge. And what was really impressive, that we do most of the challenges, but also we have a few problems that was really hard to do, because in this project was engaged more than 100 experts from different areas, and communication, develop of different milestones of our projects, common connection and challenges. We also during this time was engaged in international benchmark visit. So we received a really good experience in these matters. And also after finding or build new good practice, we see that not everything was so easy, and passion is not only important thing in our processing, and also self-discipline. That was one of the biggest problem in corporations in so huge company. So in a few months after, we tried to prepare in a new stage intelligent superfactory 4.0. Second version of our projects was also of the exogenous model, because our ministry start to find it digital innovation hub models. And what was really interesting in our case, that our consortia to this project was bigger than in the first time. So we know that we need more competences, not only one player in the area, but we need backups for different areas like cybersecurity or mechanical engineering. And also what was really interesting that some companies after the first stage of our project was not interested in further acting. So you can see on the green and red arrows that our critical mass was bigger, but we also made some selection that not everybody are interested and not only passion and self-discipline, but also really interesting is the right people in our case to realize our ideas. So after realization of second level of our projects, in fact, we finished second edition on the preparation of concept. We didn't realize this model because our ministry was not interested in realize this case. That was shorter budget for realization, and we was on the reserve list to realization of idea. So after second stage, that was for us really interesting working, because we discussed also about framework of our work and vision of develop of our idea. And after that, we discussed with our ministries about dedicated new instruments for key national clusters. We show our experience, evaluation of 3 stages of projects, also benchmarking with our partners from Romania, from France, from Denmark, from Spain, from Germany. So that was for us really interesting, not only in DigiFoF project, but also with other projects. And what was for us really important thing, that we decide to, on the preparation level, to prepare some workshop for experts and also for our member companies today, like Michał said before, to growing up the awareness of technology, of using of technology, of different aspects, business, financial, legal aspects of cooperation. And what is also really important, to ensuring our experience with metal processing cluster general assembly. A few days ago, we have very interesting consultation about intelligent superfactory and new projects, and also we made a short projects and decision, okay, we are ready to further steps, and we in the fact make some combo of endogenous of our needs and also exogenous expectation of our ministry. And we are really interested that the 5 things: passion, right people, vision, self-discipline, and framework, this is enough or not for our realization. So, in fact, in summary of my presentation, we need solution examples, but for automatic transports, sensor for automatic inventory management, common legal and technological advisor, common IT platform including monitoring. We built this platform, but technical integration, for example, UPC standards probably will be really useful for our case. And also we define the key skills and competence, process design and optimization. We are really happy that in DigiFoF projects demo lab in Białystok will be ready in a few months, and that will be placed when we will be built our skills and competence, and also technological advisory competences. We have new staff on board in September, and also sensors implementation, so the hardware of our work, and also really important things, business analytics and programmers. So we are still in process. We're not finished. I will not speak about results of our cases. So that's all for this moment, and thank you for your attention.
So I wanted to thank you very much for your first session, for interesting part. Of course, as it was told, if you have any questions, do feel free to put them in the chat. I already have one question regarding the first session from Michał. You mentioned the COVID and lockdown. Could you tell how additive manufacturing was used in Poland during the lockdown times?
Well, yes, of course. So what we did, what everyone was really doing, and that was almost not enough, which is mostly producing the face shields and perhaps some door handles, so you don't have to touch the handles as well. But as you see, these are very simple things, and we started our own design of a mask, and other. We're looking also at other FFF products, but you see, it happened so suddenly, and it actually showed the problem of not including additive manufacturing other processes, because if all these designs that could be used which could utilize 3D printing, they could be used right away. So China closed down, and all companies like us would react immediately if the contractors had the designs, had any plans in place to actually use additive manufacturing and spread out the supply chain. Because right now, one region in China got cut off. It was all. But sorry, I digressed. What we did is mainly face shields, and all bigger, smaller companies in Poland did that, and I believe that solved the problem to a certain extent, and hopefully raised some awareness of the capabilities of 3D printing.
Thank you very much. I'm looking if there are any more questions. No, I didn't see them. So once more, I would like to thank you all very much for taking time to participate in our session today, and have a good day, and see you soon on our next GoToMeeting session, on our next webinar from the DigiFoF webinar series. Thanks a lot. Bye bye.
Thank you.
Thank you.
Bye bye.
Thank you to all. Bye bye. Have a nice day.
You
Bye.
too.